Welcome to the DIY Honda Garage channel. The Honda Pilot models from 2016 to 2022 may exhibit diagnostic trouble codes DTC P2A01 and P2A04, indicating issues with the rear and front secondary heated oxygen sensor HO2S circuits, respectively. The P2A01 code relates specifically to Bank 1, Sensor 2, while P2A04 relates to Bank 2, Sensor 2. These sensors play a critical role in monitoring the exhaust gas composition and contribute to managing the engine's air-fuel mixture for optimal combustion efficiency. When the vehicle's engine management system detects that these sensors are not operating within specified parameters, it triggers the DTCs, indicating a range or performance problem. This malfunction can affect vehicle emissions, fuel economy, and overall engine performance, making it essential to diagnose and rectify these issues promptly. The DTC's P2A01 and P2A04 concern the rear secondary HO2S for Bank 1 and the front secondary HO2S for Bank 2, respectively. The HO2S are responsible for measuring the level of oxygen in the exhaust gases and sending this data to the Powertrain Control Module, PCM. The rear secondary HO2S, Bank 1, Sensor 2, is generally located after the catalytic converter, while the front secondary HO2S, Bank 2, Sensor 2, is in a similar position on the opposite bank. These sensors are critical for maintaining emission standards and ensuring efficient engine operation. If they fail or report incorrect values, it can lead to elevated emissions and degraded performance. Proper functioning requires them to operate within specific voltage ranges, typically around 1.54 volts as a threshold. The possible causes of DTC's P2A01 and P2A04 include faulty oxygen sensors, damaged wiring, or issues with the PCM. A faulty HO2S may not respond correctly to the exhaust gas, leading to a range or performance problem. Damaged or shorted wires between the sensors and PCM can interfere with signal transmission, causing incorrect readings. Additionally, issues with connecting terminals or connectors can yield intermittent performance. Resulting in these DTCs, electrical connections must be inspected thoroughly, as corrosion or looseness can easily lead to a failure in the circuit. Finally, if the PCM itself is malfunctioning, it may produce erroneous data or fail to interpret sensor inputs correctly. Each of these causes may trigger the corresponding DTC codes, requiring methodical troubleshooting to ascertain the root source. When experiencing DTCs P2A01 and P2A04, several symptoms may surface. Drivers often notice poor engine performance due to improper fuel mixture ratios, leading to sluggish acceleration or rough idling. Another common symptom is an increase in exhaust emissions, which may result in failing emissions testing. Reduced fuel efficiency can also be a significant warning sign, as a malfunctioning oxygen sensor can cause the engine to operate inefficiently. Additionally, the check engine light is likely to illuminate, prompting drivers to investigate the underlying issue. Because these symptoms can overlap with a variety of other faults, it's crucial to utilize the proper diagnostic steps to confirm the presence and specifics of the DTCs in question. To begin troubleshooting for DTCs P2A01 and P2A04, first, turn the vehicle's ignition to the on position, but do not start the engine. Upon reaching this state, utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. Once the DTCs are cleared, switch the vehicle to off mode. Afterward, start the engine and maintain the RPM at approximately 3,000 without any load until the radiator fan activates. This step is essential as it allows the vehicle's systems to detect operational readiness and status. During this process, closely monitor the onboard diagnostics (OBD) status for the presence of P2A01 and/or P2A04 DTCs in the HDS menus. If the HDS indicates these DTCs as failed, it confirms that the issue is replicated and requires further investigation. In this second troubleshooting step, turn the vehicle back to the off-lock mode. Then, disconnect the secondary HO2S sensor 2 4P connector to isolate the sensor from the system. Once this is done, switch the ignition back to on. With the HDS, check the parameters of the HO2S for both banks. Specifically, look for the signal voltage of both HO2S Bank 1 Sensor 2 and Bank 2 Sensor 2 to be less than 1.54 volts. If the readings fall below this threshold, proceed to the next troubleshooting step. However, if they do not match the expected values, it is likely that you need to replace the faulty secondary HO2S Sensor 2 to rectify the performance issue. Initially, turn the vehicle to the off-lock mode before proceeding with this step. Check for continuity between designated test points while ensuring the secondary HO2S Sensor 2 connector remains disconnected. This involves testing between the female terminals of the rear secondary HO2S Bank 1 Sensor 2 and the male terminals of the front secondary HO2S Bank 2 Sensor 2 to body ground. Establishing continuity is crucial to determine if there is a short in the wiring line between the sensors. If there is continuity, this indicates a definitive issue in the circuit that needs addressing. Conversely, if continuity is not established, it is not indicative of a fault with the wiring connected to the sensors themselves, prompting a shift to further diagnostics. To conduct the shorted wire check for lines SO2B1 and SO2B2, first jump the SCS service check signal line using the HDS and wait for more than 1 minute. After this, disconnect the PCM Powertrain Control Module connector C51P. Similar to previous checks, evaluate continuity between specified test points. This includes the female terminals from the rear secondary HO2S Bank 1 Sensor 2 connector and the male terminals from the front secondary HO2S Bank 2 Sensor 2. If continuity exists, a repair is needed for the short in the wire connecting the secondary HO2S Sensor 2 and the PCM. If continuity is not present, it suggests that the wire itself is intact, thus requiring further examination of the PCM or consultation with authorized service information. For the final shorted wire check involving lines SO2SGB1 and SO2SGB2, follow the same initial process as before by jumping the SCS line with the HDS and waiting for over 1 minute. Disconnect the PCM connector C51P to begin continuity checks. Assess continuity between the relevant test points, the female terminals of the rear secondary HO2S Bank 1 Sensor 2 connector, and the male terminals of the front secondary HO2S Bank 2 Sensor 2. If continuity is confirmed, it indicates a short present within the wiring line requiring repair. If there is no continuity, then the wiring is likely in good condition, leading you to check for authorized service information concerning the DTCs, or consider substituting with a known good PCM, monitoring for changes in DTC presence. Following the completion of any necessary repairs associated with DTCs P2A01 and P2A04, it is vital to perform a final verification. Start by ensuring that the entire system operates as intended without any errors. Clear the DTCs using the HDS and proceed with a test drive of the vehicle. This allows for real-world conditions to verify that all systems are functioning properly and that the DTCs do not return. Monitoring the engine performance and the OBD system status during this drive is crucial to successful verification. If codes do not reappear and performance has improved, the repair has likely been effective. Should any codes return, further analysis may be required to ensure all contributing factors have been addressed. Preventive maintenance is key to ensuring optimal performance and to avoid the recurrence of DTCs P2A01 and P2A04. Regularly check the condition of all connectors associated with the oxygen sensors and the PCM to ensure secure connections and detect corrosion. Periodic inspections of wiring for any signs of damage, such as fraying or exposure, can prevent electrical faults from occurring. It's also recommended to replace oxygen sensors as per the manufacturer's schedule, or when performance issues are noted. Establishing a routine maintenance plan can significantly increase the lifespan of components and enhance overall vehicle reliability. This proactive approach can help avoid unexpected repairs and ensure emissions compliance. In conclusion, addressing diagnostic trouble codes P2A01 and P2A04 requires a thorough understanding of the HO2S components and their crucial role in the emissions control system within the Honda Pilot. Proper diagnosis is essential, as these issues can affect both engine performance and emissions compliance. Following the structured troubleshooting steps ensures that technicians can identify the root cause effectively, whether it's a faulty sensor, damaged wiring, or PCM issues. By adhering to these guidelines, addressing symptoms promptly, and implementing preventive maintenance measures, owners can maintain optimal vehicle efficiency and performance, while minimizing the likelihood of recurring DTCs. Remember, a proactive approach to vehicle maintenance not only ensures compliance with emissions regulations, but also enhances the longevity of the vehicle. Please like and subscribe to the channel. See you next time.